All right, so let's dive into something pretty mind-bending today.
Yeah.
Using AI to tackle the wild world of quantum computing.
Sounds fun.
You shared this research paper with us.
Right.
Artificial intelligence for quantum computing.
Yeah.
And it's a dense one.
Oh, it is.
So we're going to try to unpack the key takeaways and figure out what this all means for the future of, well, pretty much everything.
It really is a fascinating convergence
Yeah.
of two of the most complex and potentially revolutionary technologies out there.
Exactly.
Right.
Now, I think most people get the basic idea that quantum computers are incredibly powerful,
Sure.
but they're also incredibly tricky to build and use, right?
Yeah.
It's like trying to orchestrate a symphony of atoms,
Oh,
each one more temperamental than a prima donna.
that's a pretty apt analogy.
Yeah.
We're dealing with the fundamental strangeness of quantum mechanics here.
Right.
Things like superposition and entanglement,
Yeah.
which allow qubits to exist in multiple states at once.
Right.
It's unlike anything in classical computing.
Right. And this paper dives deep into how AI is being used to address some of the biggest roadblocks in quantum computing. What really jumped out at me is how AI isn't just being used to make quantum computers a bit better.
Okay.
It might actually be the key to making them practical at all.
Yeah.
What do you think?
I think the paper makes a compelling argument for that.
Okay.
One of the core ideas is that AI's ability to find patterns in huge data sets
Okay.
is a perfect match for the complexities of quantum mechanics,
Right.
which is itself all about patterns and probabilities.
So it's like AI is learning to speak the language of the quantum world.
Yes, and perhaps even becoming fluent.
Wow.
It's being used to tackle challenges at every level,
Okay.
from the design of the physical qubits themselves
Right.
to the optimization of the algorithms that run on them.
Let's start with the hardware side then.
Okay.
This paper talks about AI being used to design and optimize qubits.
Yeah.
Can you break that down for us?
Well, think about it. Building a qubit,
Hmm.
the basic unit of information in a quantum computer, is incredibly difficult.
Right.
We're talking about manipulating individual atoms,
Yeah.
photons or electrons.
Right.
It's a delicate and error-prone process.
So where does AI come in?
Well,
Is it like a super-powered version of trial and error?
it's more sophisticated than that.
Okay.
AI algorithms,
Hmm.
particularly machine learning algorithms,
Okay.
can analyze vast amounts of data about qubit designs and performance.
Right.
They can sift through millions of potential configurations of superconducting circuits, for example, and identify those that are most likely to work reliably and efficiently.
So it's not just brute force.
Yeah.
It's actually understanding what makes a good qubit.
Exactly.
Okay.
The paper talks about AI being used to characterize quantum systems
Right.
and learn their Hamiltonian parameters.
Hmm.
Essentially, it's reverse engineering the behavior of these complex systems,
Okay.
figuring out what makes them tick.
That's really impressive.
Yeah.
But wouldn't you need a pretty robust understanding of quantum mechanics to even begin to design these algorithms?
You would.
Yeah.
And that's precisely why this field is so exciting.
Okay.
It's bringing together experts in quantum physics and computer science to collaborate in ways we haven't seen before.
Okay, so AI can help us build better qubits.
Yeah.
What about the algorithms that actually run on these quantum computers?
Right.
Those are notoriously complex too, right?
Absolutely.
Okay.
And again,
Yeah.
AI is emerging as a powerful tool for streamlining and optimizing these algorithms.
Okay, I'm all ears.
All right.
Where do we even begin with that?
Um,
The paper mentions something called unitary synthesis,
right.
which sounds pretty intense.
It is a complex concept.
Yep.
But the basic idea is to break down a desired quantum operation into a sequence of simpler steps that a quantum computer can actually perform.
Okay.
It's like figuring out the exact sequence of moves a robot needs to make to accomplish a task.
Right.
And traditionally,
Yeah.
figuring out these sequences was a very manual and time-consuming process, right?
Exactly.
Yeah.
But AI is changing that.
Hmm.
Algorithms, particularly a class called diffusion models,
Okay.
can now analyze a quantum operation and automatically generate the most efficient sequence of basic quantum gates to implement it.
That's fascinating.
Yeah.
So AI is taking something that was once incredibly complex
Right.
and making it almost
Routine.
routine.
In a way, yes.
Wow.
It's automating a crucial step in the development of quantum algorithms.
Right.
Freeing up human researchers to focus on higher-level problems.
Okay.
And it's not just about automation. AI is also being used to find more efficient sequences than humans were able to come up with.
Okay.
Which means shorter, more robust quantum algorithms.
So AI is not just speeding up the process.
Right.
It's actually improving the algorithms themselves.
Yeah.
That has huge implications.
It does.
What are some of the other ways AI is being used to make quantum algorithms better? Well, one key area is circuit optimization.
Okay.
Quantum computers are still quite limited in terms of the number of qubits they can handle.
Right.
And those qubits are very prone to errors. So it's crucial to make quantum algorithms as compact as possible, meaning they use the fewest possible steps.
So it's like finding the most efficient route on a map, but the map represents the complex world of quantum computation.
Precisely.
Wow.
And AI is proving to be incredibly good at navigating that map.
Okay.
There are algorithms that can take an existing quantum circuit,
Right.
which is essentially a blueprint for a quantum algorithm, and find ways to simplify it without changing the overall function.
Okay.
This can significantly reduce the number of qubits and the time required for a computation,
Okay.
leading to more accurate results.
This is where AI's brute force computational power really comes into play, right?
Exactly.
It can explore possibilities that would take humans years to analyze.
And it's not just about brute force. AI algorithms are getting smarter at understanding the nuances of quantum computation. They're learning to identify patterns and symmetries that allow for more efficient implementations of quantum algorithms.
It's almost like AI is developing its own intuition about how to work in the quantum realm.
That's a great way to put it.
Yeah.
And this intuition is only going to get more sophisticated as we feed these algorithms more data and refine their learning processes.
This is all incredibly exciting, but I have to admit I'm still wrapping my head around the sheer complexity of it all.
Yeah.
AI designing qubits, optimizing algorithms. It's like science fiction come to life.
It is.
Yeah.
And we're just scratching the surface.
Really?
There are even more fascinating applications of AI in quantum computing,
Oh, wow.
like state preparation,
Okay.
where AI can help us efficiently initialize the quantum computer for specific computations.
Okay, that sounds like a whole other rabbit hole to explore.
Yeah.
Let's save that for later and move on to another crucial aspect of quantum computing. Real-time control and tuning of the quantum device.
Sounds good.
Yeah.
It's an area where AI is proving to be particularly adept,
Okay.
and it has huge implications for the reliability and scalability of quantum computers.
Oh, okay.
So we've talked about designing qubits and optimizing algorithms, but controlling a quantum computer in real time,
Right.
that's a whole other challenge.
Yeah.
Imagine trying to conduct an orchestra where the instruments are individual atoms.
Oh, wow. Talk about a high-pressure gig.
Yeah.
You need a conductor who can not only read the music, but also adjust to each musician's quirks
Right.
in real time.
Exactly. You're dealing with incredibly sensitive quantum states that can be easily disrupted by the slightest noise or variation in the environment.
Right. And this is where AI steps in to be the ultimate quantum conductor, right?
Precisely. AI's ability to handle complex real-time data makes it perfectly suited for this task. Think about it. AI can analyze the state of the qubits, the environmental conditions,
Yeah.
a host of other parameters, and then adjust the control signals on the fly to maintain the stability and accuracy of the computation.
It's like having a super-powered autopilot that can keep the quantum computer on course, even in the roughest of quantum seas.
That's a great analogy.
Yeah.
And it's already happening. Researchers are using AI to optimize the control pulses that manipulate the qubits, ensuring they're playing in perfect harmony.
Right.
This is particularly important for techniques like quantum error correction,
Right.
which require extremely precise control over the qubits.
That makes sense. But how does AI actually learn to do this? It's not like we have a bunch of experienced quantum conductors to train it on.
That's a great question. One powerful technique that's being used is Bayesian optimization.
Okay.
It's a way for AI to learn from past experience and make intelligent decisions about how to control the quantum computer, even in the face of uncertainty.
So it's like AI is constantly running experiments,
Yeah,
figuring out what works best,
right.
refining its control strategy over time.
Exactly. And it's particularly effective for fine-tuning the parameters of individual qubits,
Okay.
essentially making sure each instrument in the quantum orchestra is perfectly tuned. This can significantly improve the performance and reliability of the quantum computer.
It's almost like AI is learning the art of quantum improvisation,
Right.
constantly adapting to the ever-changing dynamics of the quantum world.
Yeah.
But let's be honest, even with the best conductor, there are bound to be some wrong dots, right?
You're absolutely right.
Errors are kind of inevitable in quantum computing.
Errors are the Achilles heel of quantum computing.
Yeah.
They're like those pesky glitches that can crash your computer or corrupt your data.
Right. But guess what?
Right.
AI is helping us fight those errors too.
Oh, yeah.
Now this, I have to hear.
Okay.
How can AI possibly tackle something as fundamental as quantum errors?
Well, one of the key approaches is through quantum error correction,
Okay.
which involves encoding the quantum information in a way that makes it more resilient to errors.
So it's like having a backup system in case things go wrong.
Exactly. But here's where it gets interesting.
Okay.
Decoding these error correction codes,
Right.
meaning figuring out where the errors occurred and how to fix them, is a computationally intensive task.
Yeah.
And as the number of qubits increases, it becomes exponentially harder.
Okay, so I'm sensing a pattern here.
Yeah.
AI to the rescue.
Yeah. Okay. AI is being used to build smarter decoders that can analyze the patterns of errors
Okay.
and quickly identify the best way to correct them.
Can you give us an example of what these AI-powered decoders actually look like?
Absolutely.
Mm-hmm.
Researchers are using a variety of powerful AI architectures for this,
Okay.
like convolutional neural networks and graph neural networks.
Okay, let's break that down a bit.
Sure.
I know about convolutional neural networks from image recognition.
Yeah.
But how do they apply to quantum error correction?
It turns out that the spatial patterns of errors in a quantum computer can be represented in a way that's very similar to an image. So those convolutional layers that are so good at detecting edges and shapes in images
Yeah.
can also be used to identify patterns of errors in quantum data.
That's a great example of how AI techniques from one field can be unexpectedly applied to another.
It is.
What about graph neural networks?
Yeah.
Those seem particularly well suited for quantum computing, given that qubits are often connected in a network-like structure.
Exactly. Graph neural networks are specifically designed to analyze data that has a graph-like structure,
Oh, okay.
where nodes are connected by edges,
Right.
and in a quantum computer, the qubits are the nodes,
Mm-hmm.
and their interactions are the edges.
Okay.
So graph neural networks can be used to track how errors propagate through the system and to develop strategies for containing them.
It's like having a detective who can trace the path of a quantum error through the network of qubits.
Yeah.
But decoding errors is only part of the battle, right?
Right.
Can AI also help us prevent errors in the first place?
You're asking all the right questions.
Oh.
Yes, AI is also being used to discover new and better error correction codes.
That sounds even more challenging than decoding.
Yeah, it is.
How does that even work?
It's a bit like trying to find the perfect lock that can't be picked.
Okay.
You need to search through a vast space of possibilities, looking for codes that are robust, efficient, and tailored to the specific type of errors that occur in a quantum computer.
That sounds like a job for AI.
It is. Researchers are using a technique called reinforcement learning
Okay.
to train AI agents to discover these optimal error correction codes.
Okay.
It's a trial and error process where the AI agent is rewarded for finding codes that offer better protection against errors.
So it's like AI is playing a game where the goal is to build the most unbreakable quantum code.
Exactly. And it's already leading to the discovery of new codes that outperform those designed by humans.
Wow.
It's a really exciting area of research.
This is all incredibly impressive.
Yeah.
It seems like AI is becoming an indispensable partner in our quest to build fault-tolerant quantum computers. But we've only talked about the challenges of controlling the qubits and dealing with errors. What about the actual results of a quantum computation?
Okay.
How do we make sense of the data that comes out of these complex machines?
That's another crucial area where AI is playing a critical role.
Okay.
Extracting meaningful information from a quantum computer is like trying to decipher a message written in the language of atoms.
And AI is the Rosetta Stone that can help us translate it?
Exactly. AI algorithms can be used to analyze the raw data from a quantum computation and extract the relevant information,
Right.
filtering out the noise and accounting for the inherent uncertainties of quantum mechanics.
So it's like having a superpowered data analyst that can make sense of the quantum chaos.
That's a great way to put it.
Yeah.
And this ability to interpret quantum data is essential for a wide range of applications, from simulating complex molecules to solving optimization problems.
Okay, so AI is helping us design qubits, optimize algorithms, control the quantum computer, correct errors, and even interpret the results.
Right.
Is there anything AI can't do in the world of quantum computing?
It's certainly becoming an integral part of the field, but remember, it's not about AI replacing humans.
Okay.
It's about AI augmenting human capabilities.
So it's a collaboration, not a competition.
Precisely. AI is a powerful tool that can help us overcome some of the biggest challenges in quantum computing.
Right.
But it's human ingenuity and creativity that will ultimately guide the direction of the field.
That's a reassuring thought. But even with this collaboration, I can't help but feel like we're just scratching the surface of what's possible with AI for quantum computing.
You're absolutely right. We're still in the early stages of this incredible journey. The research is moving at a breakneck pace,
Yeah.
and we're seeing new breakthroughs almost every day.
Okay, so before we get too carried away with speculation about the future, let's take a step back and look at some of the key takeaways from this paper.
Right.
What does it tell us about the current state of AI for quantum computing?
Well, one clear takeaway is that AI is no longer just a theoretical possibility in this field. It's already being used to address real-world challenges.
Okay.
And it's having a tangible impact on the progress of quantum computing.
So it's not just hype, it's actually delivering results.
Exactly. The paper highlights several specific examples of how AI is being used to improve the performance and reliability of quantum computers. From designing better qubits to developing more efficient error correction codes.
And what about the future?
Yeah.
What does the paper suggest about the long-term potential of AI for quantum computing?
The paper paints a picture of a future where AI and quantum computers work together seamlessly to solve some of the most challenging problems facing humanity.
Like what kinds of problems?
Okay.
You give us some concrete examples.
But one area that holds immense promise is drug discovery. Imagine being able to use a quantum computer to simulate the behavior of molecules at an atomic level, allowing us to design new drugs with incredible precision and speed.
That would be a game changer for medicine.
It would, and that's just one example. Quantum computers could also revolutionize material science,
Right.
allowing us to design new materials with unprecedented properties, leading to breakthroughs in everything from energy storage to transportation.
It's like AI is giving us the tools to unlock a whole new world of possibilities.
It really is.
But there's also a lot of talk about the potential for AI to be transformed by quantum computing, right?
Absolutely. The paper hints at this intriguing possibility, suggesting that we might one day use quantum computers to enhance AI itself.
Okay, now that's a mind-bending thought.
It is.
So instead of AI helping quantum,
Exactly.
it's quantum helping AI.
Exactly.
Yeah.
It's a fascinating idea that could lead to the development of entirely new types of AI algorithms. Algorithms that are inspired by the principles of quantum mechanics.
Okay.
And capable of solving problems that are currently intractable for classical AI.
But what kinds of problems? Can you give us some examples of how quantum-enhanced AI might change the world?
Well, one area that comes to mind is machine learning. Quantum computers could potentially be used to speed up the training of machine learning models,
Okay.
allowing us to analyze vastly larger and more complex data sets.
Right.
This could lead to breakthroughs in areas like natural language processing, computer vision, and personalized medicine.
That would be huge. It's like giving AI a turbo boost, allowing it to learn and adapt at an unprecedented pace.
Right.
But this is all still very speculative, right?
It is. Yeah.
We're not quite at the point where we can build quantum computers that can run these kinds of advanced AI algorithms.
That's true. But the research is moving incredibly fast.
Okay.
We're already seeing the first tentative steps towards building quantum machine learning algorithms. And it's only a matter of time before we see significant breakthroughs in this area.
So the future of AI might be quantum.
It's certainly a possibility, and it's one that I find incredibly exciting.
Wow.
It's a future where the lines between AI and quantum computing blur.
Yeah.
And we create a new generation of hybrid technologies that can truly tackle the world's most complex and pressing problems.
This entire deep dive has been mind-blowing.
Yeah, it has.
We've gone from AI designing qubits to the potential for quantum-enhanced AI.
That's quite a journey.
It's clear that AI is not just a tool for quantum computing, it's a fundamental partner in unlocking its full potential.
It really is.
But let's not forget about the human element in all of this.
Right.
What does this partnership mean for us?
Yeah.
The people who will ultimately be using and benefiting from these technologies?
That's a great question. And it's one that we need to be thinking about very carefully as we continue to develop these powerful technologies.
What are some of the key considerations we need to keep in mind as we move forward?
Well, for one thing, we need to make sure that these technologies are developed and used responsibly.
Okay.
We need to consider the potential ethical implications of quantum computing and AI.
Right.
And ensure that they are used for the benefit of humanity,
Yeah.
not for harm.
That's a crucial point. We can't just get caught up in the excitement of the technology without thinking about the potential consequences.
Right.
Exactly. We need to be mindful of the potential risks, such as the possibility of bias in AI algorithms or the potential for quantum computers to be used for malicious purposes.
So it's not just about building these technologies.
Right.
It's about building them responsibly.
Absolutely. We
Right.
need to have open and honest conversations about the potential impacts of these technologies.
Right.
And develop guidelines and regulations to ensure they're used ethically and for the greater good.
That's a great point, and it's something that we should all be thinking about
Yeah.
as we enter this exciting new era of AI and quantum computing.
Right.
But let's not get bogged down in the potential negatives. There's so much potential for good here,
Yeah.
and I'm incredibly optimistic about what the future holds.
I share your optimism. The convergence of AI and quantum computing has the potential to transform our world in profound and positive ways, from revolutionizing medicine and material science to addressing climate change and solving some of the most fundamental mysteries of the universe. It's a future that I, for one, am incredibly excited to be a part of.
Yeah.
But before we get lost in our daydreams about quantum-powered flying cars and AI-designed cures for all diseases,
Okay.
let's bring it back to the present.
Sounds good. What specific takeaways do you think our listeners should be walking away with from this deep dive?
Well, for me, the biggest takeaway is that the future of AI and quantum computing is not just about building faster computers or more complex algorithms.
Right.
It's about using these technologies to solve real-world problems and to improve the lives of people around the world.
I completely agree. It's about harnessing the power of these technologies to create a better future for everyone.
And for you listening, we'd love to hear your thoughts on this fascinating topic. What stood out to you the most?
Yeah.
Are you as excited as we are about the potential of AI-powered quantum computing?
Right.
What kinds of problems do you think this technology could solve?
Yeah.
Let us know in the comments.
And remember, this is just the beginning. The field of AI for quantum computing is evolving rapidly, and we're only just starting to glimpse its full potential.
Thanks for joining us on this incredible journey into the world of AI and quantum computing.
It's been great.
We'll see you next time for another deep dive into the frontiers of science and technology. Okay, so we've talked about how AI is being used to turbocharge quantum computing,
Right.
but this paper also hints at a really mind-bending possibility.
Yeah.
Using quantum computers to enhance AI itself.
It's a bit of a role reversal, isn't it?
It is.
Instead of AI being the tool for quantum,
Right.
we're talking about quantum becoming the tool for AI.
Right, and that opens up a whole new can of worms, or maybe
Yeah.
a whole new quantum superposition of cans.
Let's stick with worms for now.
Okay.
The key idea is that certain types of problems, particularly in machine learning, could potentially be solved exponentially faster using quantum algorithms.
Okay, I'm intrigued. Can you give us a concrete example of how quantum computing could actually make AI smarter?
Think about the process of training a machine learning model.
Okay.
It involves analyzing massive data sets to find patterns and make predictions. Now imagine if you could perform those calculations using a quantum computer, leveraging its ability to explore multiple possibilities simultaneously.
So instead of crunching through data sequentially,
Right.
you're doing it in a massively parallel way.
Exactly. And that could lead to significant speedups in training times, allowing us to develop more sophisticated AI models that can handle even larger and more complex data sets.
That would be a game changer for fields like natural language processing and drug discovery,
Yeah.
where we're dealing with mountains of data that are currently very difficult for even the most advanced AI systems to handle.
Precisely. And it goes beyond just speeding up existing algorithms.
Yeah.
There's also the possibility of developing entirely new types of machine learning algorithms that are specifically designed to run on quantum computers.
So quantum-inspired AI.
Right.
What would those algorithms look like? What kinds of problems could they solve that classical AI can't?
That's where things get really interesting, and we're still very much in the early stages of exploration. But one area that holds a lot of promise is optimization.
Optimization? You mean finding the best solution out of a huge number of possibilities?
Exactly. Think about problems like finding the optimal route for a delivery truck, designing the most efficient financial portfolio, or even developing a new material with specific properties.
Okay.
These are all optimization problems, and they can quickly become incredibly complex as the number of variables increases.
And you're saying quantum computers could help us solve these problems more efficiently?
Potentially, yes. Quantum algorithms like quantum annealing and the quantum approximate optimization algorithm have shown promising results for solving certain types of optimization problems.
Right.
And if we can successfully integrate these algorithms into machine learning frameworks, we could create AI systems that are far more powerful than anything we have today.
Okay, I'm starting to see how this could revolutionize entire industries, but let's be realistic here. Quantum computers are still in their early stages of development. Are we really talking about something that could happen in the near future, or is this more of a long-term dream?
It's definitely still early days, but the progress is happening much faster than many people realize. We're already seeing companies like Google and IBM making their quantum computers available to researchers and developers through cloud platforms, which is accelerating the pace of innovation.
So it's not just theoretical research anymore.
Right.
People are actually experimenting with these ideas in the real world.
Exactly, and we're starting to see some really exciting results.
Like what?
For example, researchers at Volkswagen have used a quantum computer to optimize traffic flow in Lisbon,
Wow.
demonstrating the potential for quantum-enhanced AI to solve real-world problems.
That's incredibly cool. So while we might not have quantum-powered AI running our lives tomorrow, it's definitely something to keep an eye on.
Absolutely.
Yeah.
And the implications go far beyond just solving practical problems. Quantum-enhanced AI could also help us understand the nature of intelligence itself.
Now you're really getting philosophical. How so?
Well, think about it. Quantum mechanics challenges our fundamental understanding of reality. It introduces concepts like superposition and entanglement that seem to defy our everyday experience.
Okay.
If we can successfully incorporate these concepts into AI,
Right.
we might be able to create systems that think in ways that are fundamentally different from classical computers, potentially leading to entirely new forms of intelligence.
Wow, that's a truly mind-blowing thought. It's like we're on the verge of not only building smarter machines, but also redefining what we even mean by intelligence.
Precisely, and that's what makes this field so exciting.
Yeah.
We're not just pushing the boundaries of technology, we're also exploring the very nature of reality and intelligence.
So for you listening out there, what are the key takeaways from this deep dive?
I'd say the most important takeaway is the future of AI and quantum computing is deeply intertwined.
Okay.
Whether it's AI accelerating the development of quantum computers,
Right.
or quantum computers leading to new forms of AI.
Right.
These two fields are going to shape each other in profound and unpredictable ways.
And this journey is just beginning. We've barely scratched the surface of what's possible.
Exactly, and who knows what incredible breakthroughs we'll see in the years to come.
Yeah.
One thing's for sure, it's going to be an exciting ride.
Well, thanks for joining us on this deep dive into the mind-bending world of AI for quantum computing and quantum computing for AI.
It's been a pleasure.
It's been an incredible journey, and we can't wait to see what the future holds.
Yeah, me too.
And to all of you listening, we'd love to hear your thoughts.
Yeah.
What stood out to you the most? Are you as excited as we are about the potential of this technology?
Right.
Let us know in the comments.
And remember, stay curious, keep learning, and never stop exploring the boundaries of what's possible.
Until next time, keep on diving deep.